We see the 5G icon on our phones every day, but beneath that little symbol lies the most complex machine ever built by humanity. 5G isn't just 4G, but faster. It's a total reimagining of how data moves through the air and across the planet. Today, we're going deep, from the physics of millimeter waves to the invisible slices of the network, to explain exactly how 5G works. To understand 5G, we have to look at what it's replacing. 4G was built for people, for smartphones and streaming. 5G is built for everything. In this masterclass, we'll break down the three pillars of 5G: the radio access network, the core, and the edge. We'll also explain the difference between fake 5G and the real standalone version. The first major change is the air interface, known as 5G New Radio. It uses a wider range of spectrum than ever before. Low band, this is the foundation. It travels for miles and goes through walls easily. Midband, this is the sweet spot. It offers much higher capacity than 4G, but can still cover a decent area. High band, or wave. These waves are tiny, literally millimeters long. They carry massive amounts of data, think gigabits per second, but they can be blocked by a window or even a leaf. This physics challenge is why 5G architecture had to change. Because those high-frequency waves don't travel far, we use small cells. Instead of one giant tower every 5 miles, we place small, low-power stations every few hundred feet. But how do we stop signals from interfering with each other? Massive MIMO. In 4G, towers had a few antennas. 5G base stations have dozens, sometimes 128 or more. Using beamforming, the tower doesn't just blast signal everywhere. It focuses a laser-like beam of data directly at your device, following you as you move. In 4G, the core network, the brain that manages your connection, was made of physical, specialized hardware. If you wanted to upgrade it, you had to send a technician to a data center. 5G uses software-defined networking. The core is now virtualized, meaning it runs on standard cloud servers as software. This makes the network incredibly flexible. If there's a massive concert downtown, the network can automatically spin up more virtual capacity in seconds to handle the load. If your 5G feels like 4G, you might be on a non-standalone network. This is how carriers launched 5G quickly, by using new antennas but keeping the old 4G core. However, to get the ultra-low latency we were promised, we need standalone 5G. This is the pure version where every part of the chain is 5G ready, allowing for features like network slicing. With a standalone 5G core, we can perform network slicing. We can literally slice the signal into different virtual networks. One slice could be reserved for autonomous vehicles, requiring 99.999% reliability, while another slice handles casual web browsing. To make it even faster, we use edge computing. We move the processing power out of distant data centers and put it right at the base of the tower. This cuts the physical distance your data has to travel, reducing latency to near zero. 5G is also designed for efficiency. Unlike 4G towers that stay on and transmit reference signals constantly, 5G hardware has ultra-lean sleep modes. It only consumes significant power when data is actually being requested, making it far more sustainable as we scale to billions of connected devices. So, there you have it. 5G is a symphony of hardware and software, densely packed cells, targeted beams, and a brain that lives in the cloud. It's the infrastructure for the next decade of human innovation. If you enjoyed this deep dive, check the description for a full glossary of the terms we use today. Hit that like button if you now feel like a 5G expert, and subscribe to catch our next video, where we zoom in on the physics of massive MIMO. What 5G feature are you most excited about? Let me know in the comments.